Hello,
Hello,
hello.
everybody, and welcome back to the Routing Loop. I'm joined here with Matt, and Vishwash is also here. Um, Thank you for joining on. And you've joined us with obviously with the Routing Loop, which we are dedicated in helping builders and folks learn about AWS networking right from the ground up to complex networks. This is a live show, of course, so please bring your comments, ask questions. We will read them. Matt and I will do our best to try to read them and curate them for Vishwas. Um, but obviously, you guys know Matt and you know myself, but Vishwash is a little new. So why don't you introduce yourself and tell everybody kind of what you do for AWS?
Thanks, Jamie. Hi, guys. My name is Vishwas. I'm a product manager at AWS. I work on network observability across the AWS product portfolio. I joined AWS 2.5 years ago, almost coming up at three. And yeah, so happy to be on the call and talk about network observability and give you a little bit more insights on the stuff that I'm working on today.
Cool. And so, product manager, that means that you're responsible for helping design all of these wonderful networking products?
On the observability space, yes. So my job is to essentially listen to our customers, get the feedback, and see where we can address their pain points from a network observability standpoint. Basically, try and figure out how we can provide our customers more visibility to our network performance, thereby giving them the confidence that we as AWS are doing our best to give the best performance for their workloads.
And just before we get into it, on a scale of 1 to 10, one being the lowest, 10 being the highest, how important, what is the heaviest weight of a customer voice when you're designing products and features?
Well, we are customer obsessed, right? So all the we work backwards from our customers' needs. So yeah, it's probably more than 10, right? So
Okay.
I was going to
we
say the default answer is 11 on that one,
Yes, exactly.
generally.
So yeah, we work backwards from our customers' needs, and they define essentially what are the things that they would like to see us develop in the short term, in the long term. And my job is essentially making sure that we get the pulse of our customers' feedback and then convert that into deliverables that addresses their pain points.
And just for those watching, the best way to get information over to Vishwash as he's designing new observability products for us is to bring in your account team, let your SAs and let your AMs know. You can even tell them, hey, I want to talk to Vishwash or I want to talk to Jamie or Matt, and just try to get my inputs in. Our customers trying to do X, Y, Z, or of course, you would be our customer, just so that you can get your voice added too. So we're all inclusive. Everybody has a voice. Just let us know what you need from us. So at that point, I'm just going to kind of hand it over to you, Vishwash. You want me to put your presentation up?
Yes, please. Yeah. As I said, excited to be here presenting the network observability stuff that we are doing at AWS. Now, there are multiple things that we would like to talk about. The different tool sets that we provide for customers. So to kick it off, though, Matt is going to talk about a little bit about the instance monitoring side of it, where we can figure out what the network performance is at an EC2 host level. And then I would take over and talk about some of the network performance services that are available. For example, infrastructure performance, and some of the latest things that we have launched in the NPM space as well. So over to you, Matt.
Yeah, handing the microphone to me is a dangerous proposition because I'll talk for a long time, especially about a topic like observability. I think I just do want to mirror what I heard just now in that Vish is basically the PM for observability across a bunch of different services in our networking services team. And so if there are any observability requests, post them in the chat. You've got the ear of the person who will be writing and defining the documents that go into defining the products that our customers want around observability. So I think that's a huge opportunity. That said, though, we are recycling a couple of reInvent slides here, and there's a good reason for that. We had a session that had a small slice of observability at reInvent, but we got, I think it was 3 minutes to talk about this whole piece of content. So now we can actually dive into this. We've got until 12 PST. So let's dig in there. Do you want to go to the next slide, Vish? Okay. So start with instance-based monitoring. And I used to build observability platforms back in the wide area networking and network engineering world that I used to work in. And an instance for us in the networking world was basically a router. It was something that was basically processing packets. In your case on AWS, the instance is really what's receiving requests and responding to requests. And so that's a great place for observability. Let's keep going. Next slide. And so basically, we have a tool called ETH tool that you can run. Basically it runs on an EC2 instance itself, and it polls the Nitro card of an EC2 instance and pulls various statistics from the card itself. So you can see here, it's super mega small for me, but maybe folks can read this okay. If not, let us know, we'll zoom in. But things like bandwidth in allowance exceeded. So if you're exceeding the bandwidth allowance on a particular instance type, family, size, you'll actually get an alert here. Contract allowance available. You can see how many contract entries you can have on this instance, or what is available. PPS allowance exceeded, super important. So if you think about an EC2 instance, you've basically got a Nitro card or our network adapter, our smart NIC that's associated with this EC2 instance. And each host on the physical server gets a slice of that Nitro card. If you've got a 24x large instance, for example, you get that whole card, or pretty much. And basically, you'll get a certain amount of packets per second that this card can process. And that's how much bandwidth a particular instance can do. So while an instance might have a 50 gig or 100 gig network interface, each instance can only process a certain number of packets per second, and depending on frame size, it depends on how much data you can push through an EC2 instance. So the ETH tool here allows you to basically see those statistics from the Nitro card and see that in the operating system. Now, you don't want to go out to all of your 1,000 instances and run ETH tool and have a look at everything proactively. Basically, the idea of a observability system is to take telemetry data like this and feed it to a central network operations center, I guess you could call it. And so you can alert when you're seeing instances within your fleet that are exceeding some of these allowances. So Vishwas, you want to go to the next slide? Basically, here we've got a quick, this just shows you an output on an EC2 instance. It's not even really pushing any packets. So you can see how many contract allowance are available here, 136,000. I forget what instance size this was on that I ran this on, but let's keep going to the next slide. This is just a sample output. So what customers are doing is they'll run an agent typically on an EC2 instance, poll ETH tool, and get those statistics. So a common example is like a Prometheus agent. They'll then take the data from that Prometheus agent and push it to something like Grafana. And so then what you can basically do is build a full dashboard of all of your instances and see a graph of all of the metrics that ETH tool has access to on the EC2 instance. We are looking at, in the future, can we offer more statistics with ETH tool? There's always some interesting stuff that happens around containers, and if you're using a DPDK interface, and you don't get, some vendors don't get access to ETH tool because they're running DPDK, and it might be an ISV software package. So there is some nuance around this. Some other things I've seen done at an instance level are using things like eBPF to look at traffic or flows, NetFlow-like breakdown in a JSON, for example, and then feeding that to a central repository. So you can use other tools outside of ETH tool. You could use some of our partners, like there's folks like Datadog and others that have full observability platforms built around this kind of technology, or you could roll your own using eBPF again. So there's a bunch of different opportunities around having a look at the instance and seeing what metrics are actually being used and exceeded.
Hey, Matt, we got a question here about ETH tool availability. Is it on all the EC2 instances, Amazon Linux? What's the availability of this tool?
I don't know the answer to that one. Maybe in the background here, Jamie, if you want to look that one up. And I'm not overly familiar with how Bottle Rocket works either, so that's probably a good one for us to chase down as well. We'll post that in the chat. Great question though, Mario. Yeah, really good one. Okay, let's keep rolling here. I think there was another question from Ken, but I think we're going to get to that. So we'll get to that at a later stage. So instance-based monitoring, that's basically the first thing that you want to look at. My observability dream is to basically have a full visual graph or 3D graph visualization of all of my instances, showing all of my flows, taking telemetry data from all instances and seeing what those instances are talking to and how much, and feeding that into a visual representation. So as a network operations person, I can just go in and say, hey, I can see this one instance is sending gigabits per second and it's all going out to the internet to youtube.com. What's going on there? That's supposed to be an instance that's serving web data. There's something wrong there. So you could see it firsthand visually right in front of you without having to do a whole bunch of investigation to figure out what flows are actually happening on EC2 instances. And I think that is one of the biggest requests we get from customers around, hey, a VPC and EC2 instances are great, but I want to see what they're actually being used for. I want to see why I got a higher bill for that gateway, for example. I want to see what types of things these instances are talking to and whether that matches my flow profiles. And one last thing before we move on, what I'll actually ask customers to do when we, Jamie and I are solution architects, is when we sit down and meet with a customer, they'll say, hey, I've got this application, it's doing X, Y, and Z, and I've got this architecture. The first question normally out of my mouth is, hey, what does your communications matrix look like? And what that means is, what do the flows look like for the applications within your deployment? So you've got an EC2 instance, it's a web app. The communication matrix for that web app would be inbound HTTP requests to the web app. Okay, so that's one flow. You've got to allow internet access coming from the outside in for that web application, for that instance, or that fleet of instances. Maybe it's going through a load balancer first, probably. The next communications flow for that instance would be to an application instance, or maybe you've got a consolidated application and database instance, 3 or 2-tiered web application, super simple example. But then this instance should have HTTP requests coming in and application requests going out. And that instance then looks healthy and you know what's going on there. You also know if, say, it's a database, if it's talking to another database in another VPC or in another region, doing asynchronous database replication. So understanding what that communication flow is super important to understanding what your application's doing. And then what Jamie and I do is we sit down and say, okay, now we understand your flows. We can design the best architecture for you using all of the networking components we have in our tool chest, like transit gateway and peering and VPC sharing and other tools. So it's kind of the steps that we go through, but the communications matrix is super key. All right, I'll jump off my soapbox now, but
I was going to say, what's that one thing we always say? Know your flows. Know more that you know about your flows and how your network actually, you could actually make intelligent decisions and planning. So
yeah,
observability is all about that.
And observability is getting closer to that in AWS, and I want to see more tools that give you more visualization. But sorry, Vishu, you had to say something.
No. So, Matt, I was just going to add that some of those we can cover using during the network flow monitor topic, right? Which is visibility for flows, the network paths that it is taking inside AWS, and so on and so forth. So, I think you set a nice precursor to that conversation.
Perfect.
I also want to bring up the question that Ken was asking. Ken, longtime viewer of the show. Thanks for always asking great questions. But I just want to give you this context. He's asking about how they can monitor direct connect traffic, direct connect gateway traffic, especially in the public interface. So as you can frame that, as you go and dive deeper in, just keep that in the back of your mind.
Yeah, so there is a service that I want to talk about, Network Synthetic Monitor, built for the Direct Connect customers. It won't address Ken's direct question directly, but I think where he's going with is something around the lines of, hey, if there is an AWS network issue on the DX gateway or DX path, do we have a service that provides more insight into that? The answer is yes, and I would like to cover that as well.
Cool.
Okay, so thanks, Matt, for the instance monitoring portion. Now, moving on to the next phase, which is once the packets leave the instances, what tools are available for you from an native AWS network observability perspective, right? So those are the things that I want to cover in the rest of the presentation, and maybe have some time to actually do some real world demos to map what we are showing on the slide deck to the actual functionalities. So the first
we love demos, Vishwas. So anytime we can jump into the console, I think it's always a good time.
Make it more real, right? Yep, absolutely.
Yep, exactly.
Yep. Sounds good. So the first one I want to present here is infrastructure performance, right? Customers always ask us in terms of like, hey, I have deployed my workloads in the different AZs in different regions. Now I want to get an understanding of what the latencies look like between these deployments, right? What is the intra-AZ latency? What is the inter-AZ latency? And then what is the inter-region latencies? So these kind of, and this is around the latencies themselves. So and why? Because they just want to understand some kind of SLAs or expectations before they deploy the workloads to get a generic understanding of the latencies they're observing. And B, if there are any issues with their workloads or anything on the network performance side, they want to understand, okay, are there any AWS network related issues that are happening that is the cause for it, right? So again, these metrics are generic metrics, meaning they are not specific to a certain customer, but they are more based on the internal probing that we do to provide generic P50 latencies to our customers. So for a couple of slides talking about the different we do have, when we design the AZs, when we deploy the data centers within the AZs, and the way we deploy the AZs within a region, we want to make sure that there is a certain latency threshold that we adhere to, but it doesn't mean that it's always going to be the same uniform latencies because of the physical distance between the data centers and the AZs. So you would see some variance in what kind of latencies you would see, the P50 latencies. Now, the good thing is with infrastructure performance, you can set alerts and thresholds, because these are metrics that we went through CloudWatch, right? So these are essential metrics that are available to you as customers through CloudWatch, and then you can then alert on it and notify on it. For example, in this case, you could potentially set a threshold level of 6.9 milliseconds or 7 milliseconds, and say, hey, if it breaches that particular threshold, notify me that there is an increased latency between AZ2C and AZ2B in a certain region. Now, just the console experience itself, the infrastructure performance is one of the tools within Network Manager. So if you go to VPC Network Manager console, you will actually see it under the Network Manager. If you go to Network Manager console, you will see that as one of the services here, infrastructure performance. And then if you actually go to the console itself, what you would see here is essentially you can select what kind of source and destination. Yeah, thank you. Thanks, Matt, on your behalf. So here you can select the source and the destinations, and then in this case, these are two different AZs within the same region. So you can select the region and the availability zone pairs, and then you can subscribe to those metrics through CloudWatch. And once you subscribe to that, you essentially get those metrics, through CloudWatch. You will also get a timeline in terms of the metrics, and also an indication of whether the AWS network is healthy or it is degraded. And to identify that, we have a bunch of internal. So we as a cloud provider, we build a lot of internal tool sets to make sure that our network is delivering for our customers, and in terms of latencies, packet losses, and so on and so forth. So we do understand, or we know when there are certain issues that are impacting these latencies. And so when there are issues, we bubble that up as a degraded signal that you can then use for to act upon. Yeah, so for example, here we see a consistent latencies between 0.9 milliseconds to 1.03 milliseconds for the different pairs that you can set up using infrastructure performance. And again, as I said earlier, these are generic latencies and not very specific to you as a certain customer. And the specificity of these metrics, we have certain services for them, which I will cover later in the presentation. And those are metrics that are specific to your workloads, right? So infrastructure performance is like do you have latency metrics from direct connect POP to a region? I don't think we support that today, right? But this we can consider for as a feature request going forward for infrastructure performance.
See,
I would
that's how
really
it works,
love to
folks.
add. Yeah, there you go. That's a PFR or a product feature request right there. I would love to have that in infrastructure performance. We work with customers on a one-on-one basis to say, hey, we have access to those latencies internally. We can help you understand what DX pops are important. But the whole idea here is just use this tool. That would be amazing. So let's do that. I think one thing I want to call out on latency between availability zones, and the reason why this tool is so important. You might have an application that's talking from one availability zone to another. That's fine. But what happens if it does it 5 times or 10 times? And so your latency goes from being, I think the lowest one we had in our diagram before was 0.6 milliseconds, which is atypical, but it's generally less than 5 milliseconds depending on the availability zone. Some are further out than others, you can see in this tool. But if you do that 10 times or 20 times as you're fetching things as part of an application flow, you could see a massive increase in latency if you use a different availability zone. So by using this tool, we've seen customers able to position their workloads a little better to get huge reductions in latency, even though the difference between our two AZs might have been 0.6 to 2.6, right? That's 2 milliseconds every time the application hits the other side, right? So it's definitely important to think about when you're deploying applications that are latency sensitive. And when I say latency sensitive, what do you think that is, Jamie? Maybe like less than 100 milliseconds?
Yeah, pretty much. Sometimes I've dealt with some customers that are very wanting like down to 10. Right. So depending on some of our FinServ friends, and I think one of them once said that every second is $1 million. Right. So they try to shave that off as much as possible. So yeah, there's quite a bit. One thing too, I want to kind of highlight too, just for those folks that are kind of newer to AWS, when we're like, why is it that we have any type of latency at all between AZs? Just keep in mind that they are full on groups of data centers that are separated by fault planes, separated by power requirements. When you're picking a different AZ, we mean business when we say that this is a alternate path that is secure and should be on its own blast zone radius, if you will. If anything should go wrong, you can just hop over to another AZ and still be operating. So that's why there is a latency in between the two, is because of the physical cable that's being dragged across up to 500 miles between the two of them.
Yeah, I don't think there's enough space within a central geographic location to have all our availability zones right next to each other.
Yeah,
fortunately, we do want to deploy in different areas, and like you said, it could be different floodplanes, on different fault lines, or different other sides of a river, for example. And then we use multiple bridges between that river to get fiber from one availability zone to another, right? So this tool gives you that visibility into the cross AZ latency. Super important.
Yeah, and thanks, Matt and Jamie, for chiming in. Yes, the one thing that you should be aware of when using infrastructure performance is that it does not incorporate the the additional latencies you may be having through some of the VPC constructs, right? Yep, I got that. Local zones to regions AZs. We should definitely consider that. Yeah, so any latencies, so this is the latency from a physical path perspective, right? So it doesn't cover any of the latencies that are introduced by transit gateways or any of the VPC constructs that are in the path. Now this is why, and the reason why we started off with infrastructure performance is this is like a very free, it's like a free service that is available for you to get some kind of understanding on the P50 latencies. But if you want to go deeper for your workloads to cover the overlay, for example, some of the VPC constructs, the underlay, and both for packet losses and latencies, then we are going to cover some of the products such as network synthetic monitor, network flow monitor, that gives you more metrics that are very specific to your workloads, so which are coming up. Okay, so now moving on to the next suite of network performance monitoring services that are that are more, I have some of the benefits that I just mentioned previously. So now infrastructure performance was available under Network Manager. The next three services that I'm going to talk about are under the CloudWatch umbrella, right? So these are network monitoring services under CloudWatch. Now the good part is, of course, all the metrics that from these services, including infrastructure performance, are available through CloudWatch. So which is a standard way to kind of ingest that into your consolidated dashboards, for example. Okay, so now what is CloudWatch Internet Monitor, and what is its purpose? So we heard you. We've been hearing you about, hey, I moved the workloads to AWS from my on-premises locations. I had full visibility for my flows and for my traffic and for my network when it was on premises. But once I moved these workloads to the cloud, I lost some of that visibility. Now, And there is a good reason for it, because we as a managed service provider, we take care of the SLAs, we take care of the performance and all of that stuff. But when there are issues, you had asked us, hey, I want more visibility into what's actually happening to my workloads in terms of network performance. So we started on that journey, since around 2022, and we started figuring out, hey, how can we have all these internal tools and monitoring services that we have, and how can we externalize that into valuable tool sets for customers, right? So we headed on that journey, and then the first service we launched in 2023 was CloudWatch Internet Monitor, right? And the purpose of CloudWatch Internet Monitor is to give customers a generic view of what's happening on the internet, and then specifically for your workloads. For instance, if you have workloads on AWS, and they are being accessed by your users from anywhere on the internet, you want to know when they come to your web page, for example, what is the kind of performance they are getting, what kind of where are they geographically, what kind of ISPs are they coming on board through, what kind of packet losses, latencies are they having, and so on and so forth. Mind you, all of this stuff is not AWS owned network, but still we want to provide customers a view into the performance metrics for their workloads being accessed by their users on the internet. And so we have a bunch of tooling internally where we go and map out the internet. We kind of figure out, like, okay, there are users coming in geographically from this place through this ISP, through this ASN, and so on and so forth. So we have a detailed understanding of that, which we call it as internet monitoring internally. And then so based on that, we figured out, okay, can we use that information to provide you specific visibility for your workloads? Now, so on that path, we started on that path, and what we did was, let's identify the resources customers want monitoring for example, whether they're VPCs. Does it also support global accelerator? No, we don't support global accelerator today, but that is something it's something that we are considering for the future. So right now we support four resources. One is the VPC, CloudFront, network load balancer, and also workspaces. So for these four types of resources, you can set up the internet monitor, and then we can identify all the users coming into those services, and what is the generic health of those that network segment. Going a little bit deeper, as I said earlier, this is in the CloudWatch console. So if you come to CloudWatch, you'll see under network monitoring, you see three things: flow monitors, internet monitors, and synthetic monitors. The one we are talking about is internet monitors, and we'll cover the flow monitors and synthetic monitors during the rest of the presentation. So if you come to internet monitors, then you will actually start with internet weather map, right? So this is what I mean by taking the view of the internet that AWS has through the internal tooling we have, and then making it available to you as customers for free on our internet monitor console. So if you come to this particular internet weather map, it shows you all the status of the global internet, geographically. For example, here British Telecommunications on in a certain geographic area, and what kind of issues. It's an availability issue or a performance issue. Availability issue basically means that there are some packet drops. Performance issue means that there is increased latencies. And so you get a good view of that entire generic internet through the internet weather map, right? And then you can zoom into specific areas, and then you can pinpoint, for example, here there are 11 issues going on in a certain area, and then you can pinpoint to that particular place, and then you'll get more details about the impacted city network. So city network is an interesting concept, right? So the idea is that users are coming in from across the globe, coming through geographically, coming through different ASNs. So we pair the geography with the ASN, and then we coin that as a city network. For instance, in this case, ChinaNet ASN 4134 is a specific segment of the internet where we have identified a certain performance issue. And how do we make this specific, right? So we talked about the generic internet weather map. Now, how do we make this specific to your workloads? So remember, I mentioned the four resources we support. So for example, in this case, you can go and set up a something called as a monitor, And then in that monitor, you can specify what kind of workload you want to pick, right? Whether it is a certain VPC or a certain CloudFront distribution. And so once you select that particular resource, internally what we do is we look at the certain logs, whether it is flow logs or some other kind of logs, to identify for your account, for that particular resource, what are the IPs that your customers are coming in from, right, through the internet. And so we take that information and we identify, okay, so here's where your customers are coming from, and then we map that to our understanding of the internet to say, okay, these number of customers are coming in from a certain geographic area through a certain ASN, and we have noticed certain ISP issues or for that particular city network, right? And then we kind of calculate those metrics and then provide an availability score for you in terms of availability, which is essentially packet losses, and then performance in terms of latencies. And then we provide you a health score for these, and then also timelines and stuff, so you can go back in history and look at what the baseline was, what is the current status, and so on and so forth. So as I said earlier, the four different types of resources, you can track the real-time performance. You can also go back in time, and also you can optimize it, right? So for instance, this is not just about detection, but also you can optimize it. For example, if you say, oh, my workloads are coming in from a certain region and they're being impacted, now we can optimize it and say, oh, but if you move it to a different region, this is the kind of latency improvements that you can find. Or if you can advertise something with a Route 53 integration that we have, you can advertise a different route for these users, and then you can kind of optimize their experience. So I'll pause here and see, Matt, do you wanted to add anything for the internet monitor side of it from the customer experience? And
No, I think you covered it pretty well, Jamie. Anything you wanna add here, or are there any other questions?
Yeah, just one thing I'm going to just add as the elephant in the room. As we get asked all the time, why is it that we have to have these different types of observabilities and these different types of tools versus like what we're used to on-prem? And to answer that is, the cloud is different, right? The cloud network is different. It's largely software defined networking. We still do have our physical devices, but those are not obviously exposed to our customers, and we are building a software defined network on top of it. And one of the things that Vish is doing with his team is he's basically exposing safely those metrics and those numbers to you, as well as putting a bit more of those brains from the cloud on top, so that you can do things like some sort of predictive analysis, or actually look at your different internet weather from different points of view throughout the entire network. That's available to you at a click. So yes, we do understand that when you are on-prem, you get to go and plug directly into your switch, you get to plug directly into your routers and get all the information, but those don't exactly exist here at this kind of scale. So I just want to kind of throw that out there.
I think scale is the key challenge there, right? You can do traffic mirroring on an instance, and you can get those PCAP files, and the scale that you need to do that at is just massive. Wild. I mean, we see customers scale up with auto scaling 1,000 instances at a time, right? Oh, I've had
within minutes
capacity overrun within minutes. Within minutes. So doing that kind of visibility in a traditional network, I think it was a lot easier, because you're not spinning up 1,000 routers within minutes and then deleting them, right?
You have those monolithic E10Ks like Suns that cost you $10 million that have 50 blades in them, and you just monitor the whole thing, right?
You're showing your age now, Jamie. I was going to say Cat 6500, but that's fine.
How about we go back to Calpanas, Matt?
Yeah.
All right. Anyway.
Okay. Keep rolling.
Keep rolling, Vish.
Thank you. Okay. So the next one I want to talk about is CloudWatch Network Synthetic Monitor. So going back to the journey that we are on, we launched the CloudWatch Internet Monitor in early 2023, and later during that year, we launched something called as Network Monitor, which has been renamed to Network Synthetic Monitor. This is also a CloudWatch service, and you'll find it under CloudWatch Network Monitoring. Now, the background behind this is that some of our DX customers in the NRT region way back in 2022 experienced a few issues, and then we were like, how can we make this better? right? How can we notify customers, DX customers, that there were issues, and that too on the AWS side of it, right? So while we do a great job hosting customers and giving them great experience, there are certain times where we have AWS network issues, and customers wanted to get to know that much quickly, and also if it is because of the AWS network or not. So initially, this service was catered to the direct connect customers, and we would monitor only the direct connect network segments. But now it is more of a generic active probing technology. That's why we renamed it to network synthetic monitor. So the basic premise here is that it's an active monitoring solution. You can set up probes, and you can ping from one source to a destination, and then based on that, we will give you indicators when there is an AWS network issue that is kind of impacting that experience. Right. So unlike the internet monitor, where where the network did not belong to AWS, and we had other ways of coming up with the metrics to indicate its state. Here, part of this segment, part of this network path is covered by is owned by AWS, and part of it is owned by the customer or a partner, right? If you deploy a network synthetic monitor, it's essentially you're setting up a probe from AWS to an on-premises IP address, right? So you can pick on a VPC, and you can you can select a subnet as your source location, and then you can set up an active probe, and the probe supports ICMP and TCP packets. And so the pros and the packets essentially travels through a VGW DX gateway, and then to a DX router, and then to a customer on premises side, and then the responses come back. And based on that active probing mechanism, we calculate the latencies and the packet losses. Now, in order for us to know when it is not normal, we need to first compute the baseline. So we compute we compute the baseline for the packet losses and latencies for this particular probe. And then whenever that baseline is broken, we trigger an anomaly check, and then we do a health check, right? So the health check essentially means that we go and check the physical path of these packets, and see up to the AWS portion, which is owned by AWS. We go and check if there is a network issue that is impacting, or that is affecting this particular traffic, and the result of this particular anomaly. And if it is, then we vend that metric through CloudWatch as a network health indicator. Now, customers typically hook onto the signal and say, "Yep, there is a network health indicator which turned red, and so that means that on this particular probe, there is an AWS network issue that's causing this higher packet losses, or or any packet losses, or higher latencies."
I'm assuming that, well, actually, this is really useful if you have multiple DX connections, right? Because you're hitting an IP on the other side. So if you're using BGP multipath, or you're doing BFD to failover in a sub-second manner, oh, yeah, perfect. Okay, lead up to multiples there. There was a question from Tech First that I want to get to first. I don't know if this will show any decently because of the link, but there's an issue under investigation as of March 1st, 2025, where the destination of the probe is reached through transit gateway. The network health indicator may not reflect it correctly. Do you want to talk to that just for a minute?
Yes, absolutely. So so the reason why you have a VGW here and not a TGW is that we currently support the network path, the DX network path that has a VGW. So what network synthetic monitor is doing behind the scenes is that the the probe data tells us the end-to-end performance of this particular network segment, right? And then what we do is we go trace that path, and we look at all the different constructs that are in between, and then we look at the signals in those constructs to say, hey, if there's a network issue or not, and whether that is correlating to the increased latencies. Now, so that means that for today, what we do is, in that network path, if there is a VGW, a DX gateway, we have complete visibility for those hops, and we get the network health indicator, so we cover that particular path. If there is a TGW instead of a VGW, we are not looking at that particular VPC construct from a network health indicator perspective. So that particular banner that we have basically says that, and a lot of our customers, a majority of our customers, have a TGW in a DX path. So it's a note to customers saying, hey, if you have a TGW in a DX path and there is an issue with TGW, that is not reflected in the network health indicator today. But if there is an issue with the VGW or a DX gateway, it is accurately reflected in the network health indicator, right? That's what that basically that banner means.
So is this a matter of you can use TGW, but it won't alert if there's something going on in TGW at this point in time?
Correct. So what it means is if you have a TGW in a path and that is going through a DX gateway and there are issues on the DX gateway side of it or in the underlying physical network, then the NHI will still be reflective of that network health indicator. But if there are no issues on the DX gateway or the physical network path, but there is an issue on the TGW side of it, then the NHI will not reflect today, as of today, which we are addressing as we speak.
And is there
I think
any?
that's
I was going to say, is there any options? What are the alternative options for monitoring the transit gateway, possibly outside this tool, to just know that there's an issue?
I think there are transit gateway metrics that are available through flow logs and CloudWatch metrics that customers can use to identify those. But the bigger goal that we have with these services is that instead of asking customers to go do pointed troubleshooting or by themselves, like go to TGW, collect its metrics, go to DX gateway, collect its metrics, and then turn on VPC flow logs here and put everything together, the goal of these services is to do all of that behind the scenes and give customers a very strong and consistent signal, right? So that is really the benefit of these products. And a lot of the times customers have told us that, hey, you're telling me to go do 100 different things and then also analyze it on my own. Can you do a better job at it? And so this is our effort to bring those things together to provide one consistent signal. Now it's unfortunately the TGW piece, which is a big part of the DX implementations. That's a hole in our solution with network synthetic monitor, and that's why we kind of want to make sure customers are aware of some of the gaps that we have with that solution. And as I said, you can use other means to still get visibility into that, but not through the network synthetic monitor.
I can definitely
It's a
tell you
pretty
that once.
strong.
Go ahead.
I was just going to say it's a pretty strong warning, but I think it's valid. Just in the network health indicator is supposed to say everything's green and good. And the last thing we would want is for someone to be using a transit gateway and seeing packet loss and their NHI is green. Then I think they lose their faith in this product, right? So I think the call out sounds pretty strong, but I think it fairly is. I mean, we want people to know that you can still use transit gateway, but it just may not indicate the NHI true status. Sorry,
Yeah,
Jamie,
so then
you were
at that one
say
point, you just want to basically just add 1 or 2 extra steps just for transit gateway monitoring on top of this until this is resolved. But I got to be honest with you, Vish. When I was a customer, I would have given a kidney for this when I was in charge of monitoring the network, because we did exactly as you said before. Like every single service had its own logging. We pulled it all down to its own S3 bucket. We conglomerated it together. We were running Athena queries against it. I had some of our application guys create a dashboard. It would have been awesome to have this. So it's good that this is here.
Yes, and as I said earlier, now with network synthetic monitor, the NHI is relevant only to the DX path, the VGW and the DX gateway, but customers can set up the probes to monitor any IP address.
Right.
For instance, you can set up the probes between 2 AZs or 2 regions, anything that can respond back to those ICMP and TCP packets, and you'll still get the end-to-end metrics from network synthetic monitor. It's just that the NHI in that case won't be relevant because it's not a DX path, right? So we can still use the active probing metrics, very similar to, for example, infrastructure performance, right? So it's just an active probing technique to get the information, and then it is also very specific to your setup. It's not a generic metric. You are defining where your source is, which VPC, which subnet, and where your destination is. So those metrics are for your network paths.
And this is all API configurable, command line, all that stuff. Definitely build this into your automated workflows, because it is amazing information that you can get to make some just-in-time changes if you need like extremely latent or performant workloads.
Okay, and then as I said, the behind the scenes, we do a bunch of instrumentation, but for you as a customer, you don't need to deploy any agents. It is all taken care of by AWS behind the scenes. So all you have to do is go to the CloudWatch console and pick a subnet and say, hey, I want to set up a probe here to a certain destination, and all the magic happens behind the scenes. You get the end-to-end metrics. You also get a network health indicator through CloudWatch that you can use to act on, notify, trigger an alert, or whatever your workflow is.
I like that we're using the term agent in the term that I'm used to. Agents these days typically mean some kind of Gen AI agent that's doing something. Not to say you couldn't integrate something like that with this system as well. That would be pretty cool.
Yep. Yeah, this is a proper network monitoring agent. Guys. So,
A real agent,
Okay.
not like
A
one of
real
those.
agent.
Not one of those cloak
Not
and
a-
dagger, sunglass wearing AI agents.
Not a Mr. Smith agent.
Yeah, exactly.
Cool. Okay, so the last service that I want to talk about quickly is the CloudWatch Network Flow Monitor, and so this goes back to what Matt and Jamie were talking at the beginning of the session, which is, we want our customers want to know what are the different workloads that are running in their deployment. That's great. Thank you very much.
But
We can
before you
also,
keep going,
yeah.
we've disrupted your line of thought. Let's do Ken's question as well, Jamie. Is my button working? Yeah, there you go. So iPerf equivalent, we haven't discussed this, but this is more performance as opposed to availability. This would be cool. I think this is a good feature request, as in you've got a probe and now you want to say, how much traffic can I send over this link or over this path?
Mm-hmm. Yep, that's great feedback. Absolutely.
I think we've got, how many PFRs do we have right now? We have 3, so that'd be the 4th.
4.
5.
Yep.
Okay, let's keep going. Yep, over to you, Vish.
This is great. Please keep it coming. Thank you. Yeah. So we discussed monitoring the internet segment. We discussed monitoring AWS2 on-premises segments, at least from a network health indicator perspective. And now we are discussing how to monitor workloads within AWS, right? So workloads you have set up between, let's say, within an AZ, between AZs, in a VPC to Amazon S3 or RDS or DynamoDB. So these are all workloads that are within AWS, and customers want to know, hey, how are what's the kind of network performance my workloads are getting? What is the baseline? What is an anomaly? And when that anomaly happened, is that issue because of of an underlying AWS network issue, right? Because that is quintessential question that they're trying to answer, which is, if I mean, right now we don't have a clear signal whether it's an AWS issue or not for your specific workload. If you have that signal, I can do things such as, hey, if there's an AWS network issue, great, right? AWS team is going to take care of it. They're going to support team is all going to be on it and stuff like that. If it is not, then I can spend the appropriate resources and prioritize it. But at least that signal to say, should you as a customer be spending time on your side, or should AWS, or is AWS already looking at it? That is the primary benefit of both Network Flow Monitor and Network Synthetic Monitor. The other primary benefit is our support services and internal operators, service owners, they actually have a lot of these dashboards built in. So they have a good idea of, hey, if there is an issue, where in the network path is that issue, whether it's a TGW issue, and so on and so forth. So that visibility exists. So they don't have to come back to you for recreation or, reproducing that particular event, collecting more logs, and so on and so forth. So both of these will reduce the mean time to detect and mean time to remediate from both customer as well as AWS perspective. So a few highlights about Flow Monitor. It provides near real time visibility for workloads between your compute instances, whether it's EKS or EC2, going to other EC2 or EKS, or going to Amazon S3 or DynamoDB or RDS, right? So we have visibility for those flows, and then we using those flows, we can compute the performance and then be able to map that to the network and so on and so forth. Now, the key here is that this is an agent-based solution, right? Now, unlike the network synthetic monitor, so this is a passive monitoring solution. So here we need an agent. Customers have to deploy an agent. It's an eBPF agent, and the eBPF agent is deployed on an Amazon EC2 instance or a EKS node, and we don't inspect any of the. Today we support only TCP workloads. We don't inspect the packet header or the payload or any of that stuff. Basically, since it's an eBPF agent, what it means is that the kernel lets the network flow monitor agent know whenever there was a TCP handshake that occurred, when a retransmission timeout event happened, or a retransmission occurred, or a byte got sent or received. All of these are notifications that the kernel sends to anybody who is willing to listen. And in this case, it's the network flow monitor agent that is listening to these events. Now, every 30 seconds, we aggregate this on a 4-tuple basis, right? The source port, source IP, destination IP, the ephemeral port, which is the source, it could be the source port or destination port, but it's an ephemeral port, the 2 IPs and the protocol. So we aggregate that on a 4-tuple basis, not the 5 because of cardinality and stuff like that. So we aggregate at a 4-tuple basis. And every 30 seconds, we send that information to the network flow monitor backend. Now, that is where the enrichment happens, right? This is the cool part of the service, which is we go and calculate, we compute the topology for that particular conversation, right? In the sense that um, uh, you could for example, if you have the agent on an EC2 instance and that's talking to a remote IP, we don't know where that remote IP is without this additional enrichment. It could be a public IP, it could be a private IP. It could be a private IP in your account. It could be a private IP in a different account. It could belong to a public IP of S3 or through a private endpoint. It could be anything, and we won't know what it is until we actually build out that topology. And so when you onboard to Network Flow Monitor, we take the snapshot of your accounts, and then we construct this lay of the land, so to speak. Okay, the TJW is connected to an NLB, is connected to an ANF, and so on and so forth. It's private link and all of that. We kind of compute the topology very similar to, let's say, generating a topology based on traceroute data that you would have probably done with on premises, right? So we construct that particular topology, and then when we know what this particular flow is, then we can map that onto the topology and identify all the overlay and the underlay components. For example, is it going through a TGW, is it going through an NLB, and underneath it, what is the physical network that connects all these VPC constructs. Now, once all of that is developed, we know the metrics for flows, and we also know the paths they are taking. Now we sit and wait until there's an anomaly, right? So we know the baseline. For example, if you looked at some of the earlier slides, make 1.9 milliseconds latency, that is the baseline for a certain workload, for that specific workload. And let's say that 1.9 becomes 6.9 milliseconds, that triggers an anomaly for us, and we do go and do a health check on all the different layers of the AWS network. And once we identify a strong correlation, we map that to the flow, and we send it to you as a network health indicator through CloudWatch metrics. So very similar to network synthetic monitor, but in flow monitor, the main differences between synthetic monitor and flow monitor is that synthetic monitor is active probing, agentless, because we take care of it. And it is, even though the path is very similar to the workload, it is not the health of the workload itself, right? But in the flow monitor, it's the opposite of it, which is we use passive monitoring techniques. We don't send any active traffic. We listen to your workloads, and we listen to the performance of those workloads. But the rest of it, constructing the topology, health indicator, all of that stuff remains the same, right? So you can pick and choose which technology to use based on the so the you know based on what suits you best. For example, if you're a platform owner and you have access to compute resources, Flow Monitor would be a good product, because then you have real experience of those workloads. But if you're a networking owner and you don't have access to compute, but you have built the VPC by yourself, you can go and select the VPC to go with an agentless model. Right. So again, just building on top here, you can have flow monitors deployed on different EC2 instances, going through middle boxes such as transit gateway. So to the earlier question, which is, hey, if I have an issue on a transit gateway and it's impacting my workload, flow monitor catches that today, because we look at the transit gateway metrics, we look at the path, and then we provide a signal, we vend a signal that catches that particular issue. Okay, so that's all I had. Let's take a few questions. Jamie, Matt.
We've got some good ones. Just for right off the bat, just talking about RTT, right? The RTT is between two EC2 instances with flow monitor agents. As you just addressed too, it'll also take into account anything that's in the path as well. I just wanted to, that was the easiest one to pull up.
Yes. So the RTT is essentially based on the on what we see in the actual flow, right? So if the flow is between two EC2 instances, and you don't need agents on both the instances, you just need an agent on one of the instances, because we do see the handshake and everything between those two instances. So based on what we see, we can report on the round trip time for the actual workload, right? But you can replace that EC2 with S3, for example, and the mechanism still works the same.
Cool. All right, we got one from Dominic. It looks like it's a bit of a two-parter. So
this is a good one. Yeah,
it's a good one. I have a quick question. How can we monitor AWS Workspace's gateway servers in terms of streaming latency to make sure that our servers are not affected when we're talking about network performance? So they basically want to rule out network performance on the streaming. What's the best way that they can monitor for that? And he's basically, his part two is talking about DCF gateway servers, and he gives a link, but this is the major gist of the question.
Yeah. We don't have a native integration with AWS Workspace gateways from a network flow monitor perspective today. But is this something, if this is something that customers own, they could potentially deploy the network flow monitor agents to get those metrics. I'll have to get back on that, Jamie, to be honest. I need to dig a little bit deeper on that.
Okay, cool. And then we got 3 questions from Ken. Is the agent installed by default on Amazon Linux AMI? If it's not, by the way, it will definitely be a part of the repo, so you can just do a yum install. And can this functionality be available on EKS or on-premise machines? So can we put the agent on on-premise machines to take advantage of this? And is it possible to have one agent for all the tools? So one agent to rule them all.
Okay, great questions. For the first one is, no, we don't have it installed by default on Amazon Linux AMI, but they are available through as a yum repository and through Systems Manager. There's also open source available on GitHub if you want to build your own golden image. So there are like 3 or 4 different ways of deploying the agent. Can this functionality be available on EKS? Yes, you can deploy the agent as a daemon set on the EKS node. We don't make it available for on-premises machines, but theoretically you can install it and you can look at the metrics. But the prop challenge here is, since that network is not an AWS owned network, we can't calculate the topology and we can't do any of the health checks on it. Right. So that's where I would say. The third one is, yes, it'll be really good to have a one agent for all these different observability services. But today it's kind of disjoint.
The agents are married to the actual services right now.
Yes, but I'll take that as a feature request to kind of bring at least have some kind of agent consolidation.
And then we got one actually from Matt, obviously from our good friend Dominic, regarding PFRs. I have one more about VPCEs for workspaces pools. Right now, AWS announced VPCE for workspaces personal. Still waiting for workspaces pools.
Yeah, I think that's a follow-up with the team. I would guess, and I'm guessing here because I haven't spoken to the workspaces team, that's coming. There must be some reason why they haven't released it at launch. But yeah, Dominic, I'll follow up with you, and I'll reach out to the workspaces team. I also have, so this is what I have right now, and this is great. We have 2 minutes left. So I have the DX pop location support for infrastructure performance, along with local zone support, CloudFront support for CloudWatch Internet Monitor, iPerf type tool as part of CloudWatch Synthetic Monitor, Workspaces pool support for VPC endpoints. Thank you, Dominic. Can we have URLs in flow logs? I think that's a great suggestion. I've never looked at that. And can we make it easier to do packet captures? Did I miss anything?
I think
This one that Drew just pointed out, having the packet captures that they can also use to read in other things like Wireshark. So being able to export that data to other tools.
Yeah, I suppose the the flow monitor agent is probably doing something different where it's using metadata of packets as opposed to the PCAP itself, right, Vishwas? So that's why we wouldn't say, here's the actual PCAP. But I get the request. This is asked by a lot of customers, so I'll take that one on as well.
The only comment, Matt, is that it's the global accelerator support for CloudWatch Internet Monitor, not CloudFront, because that support already exists.
Oh, I miswrote that down. Okay, global accelerator.
AGA.
Perfect.
So we have we're wrapping up about 1 minute. So this is the part of the show where I usually like to ask our guests, Vish, what's the one thing from this presentation? What's the one takeaway that you want our audience members to kind of understand?
I want my audience members to try out some of the new services that we have in the network observability space, because we have come a long way from where we were to today, where these services do a lot of magic under the hood and provide customers with a very crisp signal and metrics, right? So depending on whether you have compute or you don't own compute, you can pick network synthetic monitor, network flow monitor, infrastructure performance, whatever suits your deployment style and your comfort level. I would request my customers to go and try these out. And if you try it out, A, there's obvious benefits straight away, and B, you can give us really good feedback that will make these native cloud services better.
Awesome. Well, that's the time that we have for today. Thank you, Vish, for coming on. We're definitely going to have you on for further sessions. And Matt, as always, it's awesome to kibitz with you on these things. So
Of course.
thank you, everyone, and see you
Thanks,
next
everyone.
week.
Thank you.